Request Dr. Ravichandran from Sartine Horological Private Limited. He is especially expertise in zero liquid discharge. He got various industrial sectors like pharma, automobile and textile. He had got a lot of corporate sustainability awards, especially Corporate Sustainability Award in 2001 from DuPont USA. And he also got a lot of DST grants. I request him to take a walk.
Good afternoon. Now I'll just start with where India stands in water recycling technology. Now we can be proud that we are a world-class technology in India in zero liquid discharge. And India is the first country in the world to have sewage reuse. We are the first country in the world to reuse sewage water in a refinery in 1990, and I was part of the team. Now, where is zero liquid technology heading? This is my favorite topic. Now, if you take the last 150 years of water treatment, there is no major change. Everything is going through filtration and disinfection. Then if you take industrial wastewater treatment, since 70s, industrial wastewater treatment has been in the practice. The basic treatment process has not changed since then. And in the last 30 years, membrane processes have come, and if you take the last 20 years, not much has changed. So what is the new thing we are going to talk about? So my talk is going to be on, even though the basic building blocks of ZLD are the same, the real innovation is in how do you put the building blocks together. A lot of innovations have taken place due to various constraints, and I'll just share a few things with you. The first thing is what I call layout intensification. We are converting circular tanks. Wherever you go to ETP, you will always see circular tanks all over. So we decided to convert circular tanks to square tanks. And I'll show you in the next slide the details. Then process intensification. Combine 2-3 processes together, like ultrafiltration, RO plant, put it together. Then higher water recovery, like 95%. Many of our plants in zero liquid discharge, we achieve 95% water recovery. And because of all this quality improvements, we are running right now around 15 ZLD plants. And all plants we give the same quality the customer wants 365 days a year. So this is the layout intensification. From the circular tanks, you move to square tank. So you save around 30%. The other advantage in having square tank is you can have common wall. So that saves some amount of concrete, approximately 25%. So if you move from circular tank to square tank, you will save 30% space and 25% concrete. This is an example of one of the plants in Chennai, where you can see in the ground floor storage tanks, and in the top floor you have process that is going on. This is one aspect of process intensification. The second aspect of process intensification is, if you take a standard effluent treatment plant, it's a replica of sewage treatment plant. That is how it started. You will have a bar screen, oil removal, collection tank, flash mixer, clarifier, the whole set of things. But we have to grow out of the sewage treatment plant mindset. So what we have done in most of the plants we work, we remove the bar screen, because the bar screen is meant for floating material, big floating material removal, and also oil In municipal treatment plants, STP, you need to have oil separator, whereas we don't need that in a factory. In all the plants we operate, we always segregate oil at source, because once oil mixes with water, it is very difficult to remove it. This is one of the secrets how we are able to achieve 90+ recovery in all our systems. Then we are combining flash mixture flocculator as I will show later in a static mixture format, then remove some of the feed tanks and integrate the systems. So this way, the 10, if you take an example of 10 stages, it becomes 6 stages. So this is another innovation we have done. As I said, the building blocks are the same. You integrate them in a more innovative, efficient, novel ways. So this reduces the footprint, number of items, capital cost, and once the number of systems comes down, your operating cost comes down. This is an example of chrome 6 reduction. Normal chrome 6 reduction is done by acid addition in a mixing tank and then sodium metabisulfite. However, we do it in a pipe reactor like this. So instead of open tank, you have a pipe reactor in which if you add acid and sodium metabisulfite, the sulfur dioxide will not escape out. So this way we are saving more than 60% of the chemicals. No smell comes out, and the space is saved, like you see in the next slide, where the red box, the flash mixture flocculator clarifier, one stage of clarifier is removed by process intensification. You will save almost 50% of the space with using single clarifier and static mixture. This is an example of the plant in operation in Chennai, where we are converting all the flash mixture flocculator into a static mixture. This is the another example of how the reduction in space happens. If you take any automobile industry, you will have a acid-alkali stream coming, chrome stream coming. So instead of having separate clarifiers for both, we do online chrome reduction here, and then bring it to the collection tank, and then again online alkali dosing to precipitate heavy metals, and then use single clarifier. This is another aspect of the process intensification. This is a project we have done for a factory in Bangalore. They have practically no space to walk around. It's like a space shuttle, the space station. You have to walk only within 2 feet. So we have integrated in a single skid both RO plant and ultrafiltration. And one more process static mixer is also, it is behind the photograph. This way the whole plant has become so compact, we are saving practically 50% of the space. Normally, ultrafiltration will be in a separate skid and RO plant will be in a separate skid. The third, another improvement we make in RO plant is to take the permeate from RO plant. Typically, permeate from RO plant will have 100 TDS. You again feed it through the RO plant again. That way the permeate TDS will become 30. With 30 TDS, our MB DM plant will achieve an OBR of more than 15 days. This way you can save a lot of chemicals in regeneration, because if you use a DM plant, for every 1 kg of salt removed, you are generating 2 kg of waste. So we are intensifying the use of RO plant because we are only physically separating it. That way we are reducing the waste that is coming. Another is when we are, to get higher recovery from the RO plant, we recycle the reject back to the feed tank. Instead, we'll pass it through a high permeable membrane where the permeate TDS is more than 500, 600, but the reject will will be highly reduced. This is the plant in Nasik, near Maharashtra, where if you go without the high flux reject recycle, you will have a TDS of 5,000. Whereas the moment I introduce a high permeate membrane, which is a low rejection membrane, into the reject line, my reject TDS will go up by 800. My recycle TDS will be around 500. This way we again achieve higher recovery. Okay, this is the typical evaporator, Calandria type evaporator. Now when, suppose there is a factory of, say, most of the automobile plants typically have effluent of 200, 250 meter cube per day. So when you achieve 95%, many of our clients have a problem because the Calandria cannot operate well less than 30 meter cube per day. So we have developed, so in our case, suppose I have a 200 meter cube per day client, then my reject will be only 8 meter cube per day. So this evaporator will not be useful. So we developed this jacketed evaporator, where there are no recycling. It practically requires no maintenance. It is more like a batch operated system. However, we are using it continuously. A plant is working for the last 6 years with practically no breakdown, no cleaning required in Hosur, Mailam, in Krishnagiri. The manpower required is low. It is very cheaper to operate. Capital cost is cheaper. This is another view of the evaporator. Even in the layout, there is the intensification. The footprint is quite less, and it is scalable. This is the salt we get from the crystallizer, and these are the real crystals from the evaporator. And we don't need a cooling tower. Instead of cooling tower, we go with air-cooled heat exchanger, because many automobile plants may not have a cooling tower, unlike pharma. So we don't have to go for a separate cooling tower. These are different views of the evaporator in operation. So this is the summary of what I gave earlier. We intensify the process to reduce the space, to increase the efficiency, reduce the manpower requirement, and increase the reliability of the plant. Thank you.